So now we're about to take the things we actually just got done graphing, and we're going to use inequalities. And so hopefully what you saw from our graphs was that when you have an x-intercept, a lot of times there's a sign change. You know, if you cross the x-axis, your y value goes from being positive to negative or vice versa. Sometimes it bounces off, though, so you kind of have to be careful. So what we do is we find those key points, the x-intercepts, and then we're going to test them on this number line right here. So we're going to start with this, and we're going to factor this into x minus 6, x plus 1, less than or equal to 0. So those key points are going to be at 6 and negative 1, because if you plug it in, it will indeed actually make the expression 0, which in this case is okay, because the inequality sign says less than or equal to. So I'm going to go ahead and put my negative 1 right, negative 1 right here, and clean that up. Negative 1, and then put my 6 over here. And they are included, so I'm going to go ahead and close it in. But now I have to test the intervals between and after. So from negative infinity to negative 1, so I'm going to test like negative 2. And then between negative 1 and 6, I'm going to test like 0. And then from 6 to infinity, I'm going to test like 7. Okay, so I'm going to plug those in, and we're going to see what happens. So on this first one, we're going to let x equal negative 2. I'm going to plug it into the factored form, makes it a little bit easier. So I'm plugging it in and taking off 6, so that's going to be negative 8. And then negative 2 plus 1, that's going to be negative 1. Question is that less than or equal to 0? And it comes back false, because I get positive 8 is less than or equal to 0, so that's false. So we're not going to shade that part of the interval. Now we're going to try 0. So we'll let x equal 0. And if I do that, I get a negative 6 times 1 less than or equal to 0. Negative 6 is less than or equal to 0. That is true. Negative 6 is less than or equal to 0. So since 0 works, all the values between negative 1 and 6 work. And then the last one, we'll go ahead and we're going to try 7, see what happens there. If 7 works, then that interval will work. So let's see. If I plug in a 7, I get 1 times 8 less than or equal to 0. And is 8 less than or equal to 0? That's false. So we don't want to shade there. So my solution interval is from negative 1 to 6. And we do want to use brackets because we get to include those key points. All right. So now we're going to look at one that is higher order polynomial. Just means we have higher exponent here. And so that's going to give me potentially more x, could give me more x-intercepts. Doesn't necessarily mean it will happen, but it gives me the potential to have the possibility of 3 x-intercepts. So let's find out. So we'll go ahead and start by factoring out an x. So that leaves me with x squared plus x minus 6 greater than 0. Then we'll go ahead and factor that. That'll factor into x plus 3, x minus 2. Okay, greater than 0. So I do actually get 3 unique x-intercepts. So we're going to have 0, negative 3, and positive 2. This time they are not going to be included because of my inequality sign, because that makes my expression equal 0, and I'd get a false statement. 0 is not greater than 0. So let's plot these points. So I'm going to put negative 3 here, put 0 here, and we'll put 2 right here. Okay. So once again, we need to test some intervals here. And so Just you want to pick out numbers that are easy to work with. So let's see, -4. You do like -1, +1, and like a 3 or something like that. You could choose something different if you want. By the way, I should go ahead and mark it. These are all open circles, so none of those points will have the possibility of being part of the solution set. Okay, so if I plug it, once again, I'm going to plug it into the factored form. So if I plug in -4, I'm going to end up with -4 times -1 times -6. Is that greater than 0? So you multiply that together, it's +4. Multiply that with the -6, you get -24 is greater than 0. That's false. Negative numbers are not bigger than 0. All right, now we'll go ahead and try plugging in -1. So I'd get -1 times 2 times -3, and we want to know if that's greater than 0. So I'm just plugging it in for the x's. I'm doing some of the algebra in my head to get those numbers. If not, I won't have enough space. So this multiplies to give me -2, and then negative times a negative, I get 6 is greater than 0. That's good, true. Okay, so that means all the points between work. Okay. Now we'll go ahead and try +1. So if you plug in a 1, you get 1 times 4 times -1. Is that greater than 0? Well, let's see. Here you get 4. 4 times -1, you get -4 is greater than 0. Negative numbers are not greater than 0. False. So that cancels out, or that doesn't cancel out. We just don't want to include it, so I just cross it out. Okay. Last one to test, we'll do x equals 3. So if we plug in a 3, if we plug in a 3, you're going to get 3 times 6 and then times 1. Is that greater than 0? Yes, a bunch of positive numbers multiplied together is going to stay positive. And so true. So that shades from 2 to infinity. Okay, so now to write this in our interval notation, it's going to be from -3 to 0, union, from 2 to infinity. So if you plug in any one of those values in those sets, your inequality will come back as a true statement. All right, last one. Here we go, last one, and it's a rational one. And so the key points that we're going to look at here is x-intercepts and actually the vertical asymptote, because a lot of times when you go to the other side of a vertical asymptote, there's a sign change. Not always, but typically, if we go back and look, actually, you can see from this graph right here, approaching it from the left, it goes down, but once you cross it, all of a sudden it's a positive number. So I don't want to say that always happens, because sometimes sometimes it kind of looks more like this right here. I mean, there is a sign change you can see from blue to the green part, but sometimes your graphs, for example, can kind of be back to back like that wherever that asymptote is. So anyways, I don't want to say that it's always like that there's a sign change, but a lot of times there is. Okay. All right, so back to our problem at hand. All right, so to figure out the x-intercept, you take the numerator and set it equal to 0. So x plus 3, set that equal to 0. Subtract 3, you're going to get x equals -3. Okay. So that is one of your key points where there's going to be a sign change. And then now we'll find the vertical asymptote. And you take the denominator, actually, let me write that down. You take the denominator and set that equal to 0. So take the denominator, set that equal to 0. So x minus 5 equals 0. Go ahead and add 5. All right. So we'll go ahead and put -3 right here, and we'll put 5 right here. All right. Now, to whether you include them or not, so for the x-intercept, sometimes the x-intercept can be included. Okay. When you plug in -3, it causes your expression to go to 0 because you get a 0 on top, and then on bottom you get -8. But anyways, that would simplify to 0. So the 0 is less than 0. That comes back false. So that's got to be an open circle. Okay. The vertical asymptote has to be an open circle also, but that's because you can't divide by 0. If you plug in 5, you'd get undefined, and so we can't do that. All right, so now we need to go ahead and test some points. So from -infinity to -3, so we'll try like -4. And then between them, 0 is always good, so we'll test 0. And then somewhere after 5, like a 6, that would be good. All right. So let's see, if I plug it in, let's see, I'm going to get -4 plus 3 over -4 minus 5, and we want to know, is that greater than 0? So I end up getting -1 over -9 greater than 0. That actually is true because double negatives, when you take the quotient, turn to a positive. So positive numbers are greater than 0, so that is true. So we'll go ahead and shade there. Now we'll try 0. Let's see. If we plug in 0, let's see, we get 0 plus 3 over 0 minus 5. Is that greater than 0? So we end up with 3 over -5, which is a negative number. Negative numbers are not greater than 0, so that's false. So we don't want to shade right there. All right, last one, we'll try 6. So if you plug in a 6, let's see, you get 6 plus 3 over 6, take away 5. Is that greater than 0? This time we end up getting 9 over positive 1. Yep, 9 over 1 is greater than 0. That's going to come back as true. So we'll go ahead and shade from 5 to infinity. All right, so now we just have to write this in interval notation right here. So it's going to be from -infinity to -3, union from 5 to infinity. All right, that does it.